Welcome to Brain Vision.
So we have a skydiver jumping out of a balloon. We can write the energy equation, starting with the sum of the kinetic energy and the potential energy, which equals the total work. And the only work done in this system is going to be from air resistance, because I'm calling gravity part of the system, so we get gravitational potential instead of work done due to gravity. So this equation is going to carry us through the whole problem. Now, the first part, we want to find the final velocity of the skydiver. So let's just expand out all these terms. We have 1/2 m times the final velocity squared minus the initial velocity squared. And then we're going to add in mg delta h for the change in gravitational potential, and that equals the work due to air resistance. Actually, I can expand that too. That's going to be, well, we have two different sections, one where we don't have a parachute and one where we do. So I'll say the first section without the parachute is an air resistance F1 times a distance d1. And for the second section, we have F2 and d2. And for each of these sections, the air resistance is pointed up, and the skydiver is falling down, so it's doing negative work because they're in opposite directions. So each of these are going to be negative. Now we're looking for the final velocity, so I'll solve for that. Initial velocity is 0, so we can just get rid of that. So this is 1/2 times m times vf squared, and I'll bring this term to the other side. So we have minus f1 d1 minus f2 d2 minus mg delta h. And then I'll divide by m, multiply by 2. So I get 2 times minus f1 d1 minus f2 d2 minus mg delta h. Divide by m and then take the square root to get the velocity. So we'll plug in all these numbers. The first air resistance is 50 newtons over a distance of 800 meters, because we're falling from 1,000 meters to 200 meters. And then the second air resistance is going to be 3,600 newtons times the last 200 meters. And then we'll subtract out the mass of the diver is 80 kilograms times 9.8, and delta H, well, we're falling, so we're going from 1,000 meters to 0 meters, so the delta H is actually minus 1,000 meters, because it's going to be H final minus H initial, and then divide by the mass. And so we get a final velocity which equals 24.5 meters per second. And this most certainly will kill the diver, because this is over 50 miles an hour hitting the ground. So for the second part, I do not think the skydiver will survive with no injuries. Now we want to find the height to open the parachute to get a 5 meter per second collision with the ground. So we can go back to this initial equation we had here. I'll start with this one, and I'll say, so we're looking for when the parachute should be open. So that's going to be at height 2, basically, distance 1 and distance 2. So let me just rewrite this equation. We have 1/2 mvf squared plus mg delta h equals minus f1 d1 minus f2 d2. And now we know the final velocity. It's not this answer we got in the last part, but it's given to us as 5 meters per second. And so we know that, well, we're looking for basically d2. So we can substitute in d1 as going to be 1,000 meters minus d2, because d1 plus d2 has to be 1,000 meters. And then minus f2 d2, and if we can solve for d2, that'll tell us the height when the parachute should be open, because the second distance is when the skydiver travels when the parachute's open. So let me just solve for that. Expand this out. Let's say minus 1,000 times f1 plus f1 d2 minus f2 d2. So this is going to be minus 1,000 f1 plus d2 times f1 minus f2. And so I'll solve for d2. This is going to be 1/2 mvf squared plus mg delta h, and then I have to move this over to this side, so this is going to be plus 1,000 f1, and then divide out by this, so f1 minus f2. Now we'll plug in all these numbers, we get 1/2 times 80 kilograms times 5 meters per second squared plus 80 kilograms times 9.8, and again the delta H is negative, so it's minus 1,000. And then add in 1,000 times the initial air resistance, which is 50 newtons, and we'll divide out by 50 newtons minus 3,600 newtons, and so we get a d2 which equals 206 meters. So that's when you have to open the parachute to hit the ground at 5 meters per second. But through this whole problem, we've been assuming that the air resistance is constant through this whole thing, which is not actually true, because air resistance depends heavily on how fast you're moving through the air. So this assumption we're making is a bit of a generalization, but the air resistance isn't really going to be constant unless you're moving at a constant velocity.